0.8 seconds. That is the exact amount of time it takes for a determined intruder to bypass the security device you trust with your life. You look at your front door and see a barrier. A criminal looks at your front door and sees a simple physics equation that solves itself with a single application of percussive force. The deadbolt you locked before going to bed is not a guarantee of safety. It is a lie sold to you by an industry that prioritizes profit over structural integrity. The hardware store standard is designed to keep out the wind and honest neighbors, not a predator fueled by adrenaline or narcotics. Most homeowners operate under a dangerous delusion regarding the strength of residential architecture. You believe the lock holds the door shut. This assumption is mechanically false. The lock is merely a piece of hardened steel interacting with a piece of brass, which in turn interacts with a soft pine frame. When a standard adult male applies a front kick to a door, the kinetic energy generated can exceed 1,500 newtons of force. This energy travels from the boot through the door surface and concentrates entirely on the weakest point of the system. That weak point is almost never the steel bolt itself. The steel bolt is stronger than the wood it is embedded in. When that kick lands, the bolt acts like a chisel. The force drives the metal through the thin strip of wood known as the door jamb, shredding the grain and blowing the frame apart. The door opens not because the lock was picked, but because the structural support for the lock ceased to exist. This failure is engineered into the very design of modern housing. Construction companies and hardware manufacturers utilize what is known as Grade 3 residential security hardware. Grade 3 is the lowest acceptable rating for a locking mechanism. It is built to withstand minimal force and basic manipulation. Worse, the screws provided with these retail lock sets are typically only half an inch long. These short screws bite only into the decorative trim of the door frame, a piece of wood barely thicker than your finger. They do not reach the structural studs of the house frame. You are essentially locking your safety to a piece of cosmetic molding. The intruders know this. The criminals scouting your neighborhood do not need lock-picking tools or tension wrenches. Those tools belong to spy movies and hobbyists. In the brutal reality of home invasions, speed is the only metric that matters. A dynamic entry relies on overwhelming violence of action. The sound of splintering wood is the signal that your perimeter has been breached. By the time your brain processes the noise of the door jamb failing, the threat is already inside your sanctuary, closing the distance between the entryway and your family. You might think an alarm system mitigates this risk. This is another trap. An alarm system is a reactive measure. It signals that a breach has already occurred. It is a historian, not a bodyguard. The police response time in major urban centers averages between 7 to 15 minutes. In rural areas, that time extends indefinitely. A violent encounter in a home invasion is often decided in the first 30 seconds. Relying on law enforcement to intervene during a dynamic breach is a mathematical impossibility. You must buy time. You must convert your door from a cosmetic flap into a hardened barrier that forces the attacker to exhaust their energy and abandon their objective. The solution does not require thousands of dollars in reinforced steel doors or high-tech smart locks that can be hacked. Physics does not care about the price tag of your gear. Physics cares about material density and force distribution. You can achieve a superior level of hardening using materials you likely have rotting in your garage, or can purchase for less than the price of a cup of coffee. The goal is to transfer the kinetic energy of the kick away from the weak cosmetic wood and into the structural skeleton of the building. To understand why the $5 fix works, you must first understand the mechanics of the failure in greater detail. When the bolt is engaged, it sits inside a metal cup called the strike plate. In a standard installation, this strike plate is held in place by two small screws. Under impact, the stress is applied laterally to these screws. Because the screws are short, they have very little shear strength resistance against the wood fibers. The wood splits along the grain. Wood is an anisotropic material, meaning its strength depends on the direction of the force relative to the grain. A kick applies force perpendicular to the grain, which is the exact orientation where pine is weakest against splitting. The industry ignores this biological fact of lumber. They sell you the illusion of the heavy brass handle and the solid-feeling key turn. They distract you with aesthetics. Aesthetics get you killed. A beautiful door with a weak frame is simply a coffin lid waiting to be opened. The strategy we will deploy utilizes basic carpentry principles to weaponize the structure of your house against the intruder. We are going to bypass the weakness of the trim and anchor your security directly into the jack studs and king studs that hold up the roof of your home. By doing this, we change the equation. We force the intruder to fight the entire house rather than just a strip of pine. When the energy of a kick is distributed across the structural frame, the door flexes but does not break. The shock travels back into the leg of the attacker, often causing injury to the aggressor rather than failure of the entry point. This is the essence of defensive architecture. You do not need a contractor. You do not need a permit. You need a drill, a specific type of screw, and a piece of scrap wood. However, simply driving long screws into the frame is only the first step. There is a secondary failure point that most amateur survivalists miss. Even if the strike plate holds, the door itself can split down the middle if it is a hollow core design or made of composite materials. We must address the distribution of force across the surface area of the door edge. The concept is simple. Force equals mass times acceleration. To stop the mass and acceleration of a breach, you must increase the resistance of the material to a point where it exceeds the human capacity for generating force. A 200-pound man can generate a significant impulse, but he cannot kick through a 2x4 stud braced by a header and footer. Your objective is to link the moving part, the door, to the static part, the house frame, so securely that they become a single unit. We will begin by dismantling the existing hardware. This process reveals the frightening inadequacy of what is currently protecting you. As you unscrew the strike plate on your own door, look at the screws. Look at the tiny shards of metal that stand between you and the outside world. It is insulting. It is negligence on the part of the builder. But today, we correct that negligence. We will replace reliance on hope with reliance on tensile strength. Discard the factory hardware immediately. Those half-inch screws are not fasteners. They are merely placeholders designed to keep the plate from falling off during shipping. To anchor your security into the reality of physics, you must bridge the gap between the cosmetic frame and the structural skeleton of the house. This gap is typically occupied by drywall, shims, or empty air. You need to penetrate at least 2 inches of solid lumber to achieve maximum holding power. This requires replacing the standard screws with 3.5-inch or 4-inch heavy-duty construction screws or deck screws. Do not use drywall screws. Drywall screws are brittle. They are designed to hold paper and gypsum, not to withstand the dynamic shear force of a boot heel. Under impact, a drywall screw will snap. A construction screw will bend but hold. Begin the hardening process at the strike plate. Remove the existing short screws one by one. Drive the long screws into the holes until they bite deep into the stud behind the frame. You will feel the difference in torque. The screw is no longer spinning in soft pine trim. It is anchoring into the jack stud, the vertical beam that bears the weight of your roof. You are now mechanically linking your lock to the structural integrity of the entire building. When an intruder kicks the door now, they are no longer kicking a piece of trim. They are kicking the wall itself. The force required to shear a 4-inch steel screw embedded in a 2x4 stud is exponentially higher than the force required to split a door jamb. The energy of the kick has nowhere to go, so it reflects back into the attacker's leg structure. However, the strike plate is only half of the equation. A common error in defensive fortification is ignoring the hinge side of the door. A chain is only as strong as its weakest link, and on many residential doors, the hinges are the failure point. If the lock side holds rigid, a savvy attacker will shift their focus to the hinges. The standard hinge screws are just as short and pathetic as the strike plate screws. If the lock does not yield, the door can be kicked completely off its hinges, folding inward like a trap door. You must repeat the process here. Remove 1 screw from each hinge, specifically the screw closest to the weather stripping, and replace it with a 3-inch screw that reaches the stud. Do not remove all screws at once, or the door will miss alignment. By anchoring the hinges to the frame, you ensure the door remains vertical and seated in the frame, even under catastrophic impact. Now we introduce the scrap wood. The screws harden the existing system, but the wood provides a secondary, redundant barrier that functions independently of the lock. Locks can be picked. Locks can be drilled. A physical barricade relies on geometry, not complexity. We will construct a floor cleat or a Deadman brace. This is the simplest, most brutal application of friction and compressive strength. Locate a piece of scrap lumber, such as a 2x4, or even a thick piece of plywood. Cut it to a length that spans the width of your door frame plus 6 inches. If you do not have a piece that long, a shorter block will suffice for a floor anchor. The objective is to create a physical wedge. Place the wood flat on the floor, perpendicular to the closed door, centered exactly where the force of a kick would land. Screw this block directly into the floorboards using the same 3-inch screws. You are creating a static obstacle that the bottom of the door must shear through to open. For a more advanced application of scrap wood, we look to the concept of the drop bar. Commercial buildings use steel bars. You will use wood. Cut 2 small blocks of wood to act as brackets. Screw these blocks into the jack studs on the wall on either side of the door frame, not onto the door itself. These brackets must be anchored deeply. Then cut a longer piece of wood, your bar, to drop into these brackets across the door. This system distributes the force of a breach across the entire horizontal width of the wall. When the door is kicked, the force is transferred from the door surface to the bar, from the bar to the brackets, and from the brackets to the wall studs. The lock mechanism is completely bypassed in this equation. The intruder could drill out the lock cylinder entirely and the door still would not open. The door is effectively part of the wall. This method operates on the principle of distributing load. A standard door lock concentrates all force on a surface area of less than 1 square inch. That is a point failure waiting to happen. By utilizing a drop bar or a floor cleat, you expand the surface area receiving the force to dozens of square inches. You are lowering the pressure per square inch, PSI, on your defense materials while maintaining the same level of resistance. It is basic engineering. The intruder is trying to punch a needle through a balloon. You are turning the balloon into a tire. Consider the psychological impact on the aggressor. The predator expects a rhythm: approach, kick, breach, enter. This OODA loop, observe, orient, decide, act, is disrupted when the expected physics fail. The first kick usually lands with maximum power. If the door shudders but does not give an inch, the kinetic feedback travels up the attacker's skeleton. It causes pain. It causes confusion. The element of surprise shifts from the attacker to the defender. The noise of the failed attempt alerts you, giving you those critical seconds to arm yourself or escape. The intruder is now standing on your porch with a bruised leg, looking at a barrier that defies their understanding of residential construction. The cost of this upgrade is negligible. The screws cost pennies. The wood is likely free if you scavenge it. Yet, this $5 modification outperforms smart locks costing hundreds of dollars. The technology industry wants you to believe that security comes from Wi-Fi connections, cameras, and biometric scanners. Electronics are fragile. Wood and steel are absolute. A camera records your demise. A reinforced door prevents it. Do not conflate surveillance with security. Seeing the threat does not stop the threat. Friction, shear strength, and material density stop the threat. There is a caveat to this hardening. You must ensure that your reinforcement does not create a fire trap for your family. A floor cleat or drop bar must be easily removable from the inside by a child or an elderly person in the event of a fire. Survival is a balance between keeping threats out and allowing egress for escape. Do not permanently screw the door shut unless it is a secondary entry point you never intend to use. Practice deploying and removing your scrap wood barrier until it becomes muscle memory. In a smoke-filled room, your hands must know the terrain. You have hardened the skeleton of your home, but do not mistake this for total victory. A fortress with a paper gate is not a fortress. It is a funnel. We must address the door slab itself. In modern suburban housing developments, the front door is frequently a hollow core unit or a thin fiberglass shell filled with insulating foam. These materials are designed for thermal efficiency, not ballistic or blunt force resistance. When the frame holds rigid because of your 4-inch screws, the kinetic energy of a kick must dissipate somewhere else. If the door is weak, the door itself will fold. The lock remains in the frame, but the door splinters around it, allowing the intruder to simply step through the debris. The construction industry calls these standard entry doors. A survivalist calls them concealment curtains. They hide you from view, but they do not hide you from force. If you cannot afford to replace a hollow core door with a solid wood or steel reinforced unit, you must mitigate the structural weakness using the materials you have at hand. The objective is to prevent the deadbolt from tearing through the door skin. This brings us to the concept of the poor man's astragal. Stand outside your home and look at the gap between the door and the frame. If you can see the metal bolt of the lock, you have a critical vulnerability. A visible bolt is an accessible bolt. A savvy intruder can insert a pry bar, a heavy screwdriver, or even a stiff credit card into that gap to manipulate the latch or apply leverage to bend the bolt. Leverage is a force multiplier. A simple crowbar can generate thousands of pounds of spreading force, popping the bolt out of the strike plate without a single kick being thrown. To defeat this, you need a strip of wood. This is the astragal. It is a piece of molding or flat lumber attached to the outside edge of the door, overlapping the gap. It acts as a shield. By screwing a simple 1x2-inch slat of wood along the entire vertical length of the door edge, you deny the intruder access to the gap. You eliminate the fulcrum point required for a pry bar to operate. The tool has nowhere to bite. The intruder strikes wood instead of metal. This modification costs practically nothing if you use scrap lumber, yet it completely negates a primary method of non-destructive entry. We must also confront the most glaring oversight in residential security, the window. Many entryways feature decorative glass panels or sidelights immediately adjacent to the doorknob. This is architectural insanity. Glass is not a barrier. Glass is a crystallized liquid that shatters under minimal stress. An intruder does not need to kick your door if they can simply break a pane of glass, reach their arm inside, and unlock the deadbolt from the interior. Your 4-inch screws and reinforced strike plates are rendered useless by a simple thumb-turn mechanism. The hardware store solution is a double-cylinder deadbolt, which requires a key on both the inside and the outside. This is a death trap. In the event of a fire, a gas leak, or a carbon monoxide emergency, fumbling for a key to exit your own home is a fatal error. Hypoxia and panic destroy fine motor skills. You will burn to death trying to find the key to your own front door. Do not install double-cylinder deadbolts on primary escape routes. Instead, you must harden the glass or deny the reach. If you cannot afford polycarbonate sheets to replace the glass, use the scrap wood solution to physically block the hand path. Screw a decorative grill or a simple mesh of wooden slats over the interior of the window. The goal is not to stop the glass from breaking. The goal is to stop a human arm from fitting through the hole. If the arm cannot reach the thumb turn, the lock remains secure. This is crude, but effective. You are trading aesthetic purity for tactical denial. Now consider the lock hardware itself. Remove the deadbolt assembly from the door and examine the internal connecting screws. These are the 2 long screws that clamp the inside and outside halves of the lock together. In cheap grade 3 locks, these screws are made of soft pot metal. A heavy hammer blow to the exterior lock face can shear these screws, causing the lock to fall apart. Replace these internal screws with high-tensile steel equivalents of the same thread pitch. This costs pennies at a fastener supply shop, but increases the shear resistance of the lock body significantly. Everything we have discussed operates on the principle of increasing the time to entry. There is no such thing as an impenetrable barrier. Given enough time and heavy tools, a determined attacker will breach a bank vault. But home invaders do not have time. They operate on a strict adrenaline clock. Every second of delay increases their exposure to witnesses and law enforcement. Every loud noise caused by a failed kick spikes their cortisol levels. When your door absorbs the first impact without yielding, and the second, and the third, the psychological state of the predator shifts from aggression to flight. They are looking for prey, not a fight. By turning your door into a fight, you force them to select a softer target. You have now reinforced the frame, the hinges, the gap, and the lock body. You have done this for less than $5 using construction screws and scrap wood. You have utilized physics to defeat brute force. But the physical barrier is only the first layer of the onion. The next layer is the information war. An intruder scouts before they strike. What is your house telling them? Is it inviting them in, or is it broadcasting a warning? The way you maintain your perimeter speaks a language that criminals understand fluently. We must learn to speak this language. Information is ammunition, and your front yard is constantly broadcasting data to anyone who cares to listen. The security industry has convinced millions of homeowners to plant small plastic signs in their lawns that proudly display the name of their alarm company. This is not a deterrent. This is a dossier. By displaying that sign, you are telling the criminal exactly which system you are using. You are handing them the schematic. If a professional thief knows you use a specific brand of wireless sensor, they know the specific frequency required to jam that sensor. You have traded operational security for a false sense of branding. Furthermore, aggressive signage like "We don't dial 911" or images of firearms does not scare a hardened criminal. It advertises that there are high-value weapons inside the house to be stolen. Most burglaries occur when the house is empty. By advertising you are a gun owner, you are placing a bounty on your own property. The goal of survival is not to intimidate. The goal is to remain uninteresting. You want your home to appear visually boring, but structurally impossible to breach. This is the architectural application of the gray man theory. Your house should look like every other house on the block, right up until the moment someone tries to kick the door in. We must now weaponize the landscape. Biology offers a barrier system that is cheaper and more effective than any fence you can buy at a hardware store. A wooden fence provides privacy, which actually aids the intruder. Once they hop the fence, they are hidden from the street and can work on your windows in peace. You need a barrier that inflicts pain. You need tactical botany. Plant dense, thorny vegetation under every ground floor window. Species like berberis, holly, or firethorn are not just decorative plants, they are biological barbed wire. The thorns of the firethorn bush contain chemical irritants that cause lasting inflammation. When an intruder attempts to navigate through a dense thicket of these plants to reach a window, the physical trauma is immediate. Clothing tears, skin shreds, DNA is left behind on the thorns. Pain is a universal language that bypasses the logic centers of the brain and triggers the retreat reflex. A motion sensor might beep, a hawthorn bush bleeds. The industry wants you to buy glass break sensors. Nature gives you a wall of spikes that requires only water and sunlight to maintain. Combine this biological warfare with the physics of light. Darkness is the ally of the predator. Most homeowners install porch lights that they leave on all night. This is a mistake. Constant lighting creates deep, predictable shadows that an intruder can map and utilize for concealment. Static lighting allows the eye to adjust, the pupil constricts, and the intruder becomes comfortable in the environment. The superior tactic is sudden, high-intensity illumination. Motion-activated floodlights utilizing LED technology do not just reveal the intruder, they assault the visual cortex. When a 2,000 lumen light triggers in total darkness, the human eye requires several seconds to adjust. During those seconds, the intruder is effectively blind, while they are perfectly visible to you and the neighborhood. You are stripping them of their concealment and their vision simultaneously. This sudden change in the environment disrupts their OODA loop again. They feel exposed. They feel watched. The psychological pressure mounts. Let us return to the door for a final piece of scrap engineering. We must address the viewing port. The standard peephole is a fatal weakness. It offers a limited field of view, often less than 160 degrees. An attacker can easily stand to the side of the door, ring the bell, and remain invisible to you. Worse, reverse peephole viewers are readily available online. These optical devices allow a stranger to look into your home through your own peephole to see if you are present or to scout the layout. Your observation tool has become their reconnaissance tool. The solution is digital or mechanical displacement. If you cannot afford a camera system, simply remove the peephole and replace it with a solid bolt, or cover it permanently. Do not engage with a threat through a pinhole. If you must see out, use a window in a different room that offers a view of the porch. Never stand directly behind the door you are investigating. If the intruder decides to fire a weapon through the door, the fatal funnel is directly behind the peephole. By viewing the porch from a side window, you maintain a tactical angle. You can see them, they cannot see you. You are operating from a position of geometric superiority. We are building a system of layers. Layer 1 is the psychological deterrence of the gray man facade. Layer 2 is the biological pain of the landscaping. Layer 3 is the sudden exposure of motion lighting. Layer 4 is the hardened frame and the reinforced door. Each layer buys you time. Time is the only currency that matters in a survival scenario. You are not trying to build a bank vault that can withstand a siege. You are trying to build a system that demands more time and energy than the intruder is willing to spend. The criminal acts on a risk-reward calculation. They want high reward for low risk and low effort. By installing 4-inch screws, a scrap wood drop bar, and planting thorny bushes, you have drastically skewed the equation. You have made the effort astronomical and the risk of injury certain. You have made your home mathematically undesirable. The intruder will move on. They will find a neighbor who still trusts the half-inch factory screws. They will find a victim who believes the lie of the standard lock. It is a harsh reality, but survival is a zero-sum game. The predator must eat, but they will not eat at your table. Now, we must synthesize these tactics into a final manifesto. We must look at the philosophy of the $5 fortress not just as a home improvement project, but as a rejection of the victim mindset. You are taking back control of your safety from the manufacturers and the state. This $5 upgrade is more than a home improvement project. It is a fundamental shift in your philosophy of existence. You have taken a piece of scrap wood and a handful of steel screws, and with them, you have dismantled the lie of the security industry. The manufacturers want you to believe that safety is a product you purchase in a blister pack. They want you to remain a dependent consumer, forever upgrading to the latest smart lock that offers convenience but lacks structural reality. By hardening your entryway with basic materials, you declare that you are no longer a passive victim waiting for a rescue that will not arrive. You are an active engineer of your own survival. Consider the physics of what you have built. You have created a system where the kinetic energy of an attack is no longer absorbed by a fragile strip of pine trim. Instead, that energy is distributed into the deep, load-bearing skeleton of the house itself. The 2x4 studs, the king posts, and the floor joists now share the burden of your defense. You have recruited the very architecture of your home to fight alongside you. This is the essence of asymmetry. The intruder brings the limited energy of their muscles. You counter with the static mass of an entire building. It is a mathematical equation that the intruder cannot solve with violence. This approach reveals the terrifying fragility of the society around you. Look at the homes of your neighbors. They are likely protected by the standard grade 3 locks and the half-inch screws we discarded. Their security is an illusion, maintained only by the social contract. The only reason their doors have not been kicked in is because no one has tried yet. They are living on borrowed time, banking on the hope that civility will endure forever. But history teaches us that civility is a thin veneer. When the economy buckles, or the grid fails, or the desperation of the populace rises, that veneer cracks. When it does, the social contract evaporates, and all that remains is the laws of physics. In that moment of chaos, the difference between life and death will be measured in inches of steel and density of wood. When the predator walks down your street, testing the perimeter, they are looking for the path of least resistance. They will kick the door of the prepared survivalist, and they will feel the jarring stop of a reinforced frame. The shockwave will travel up their leg, signaling that this target is hard. Predators do not hunt hard targets. They hunt the weak. They will move on. They will bypass your fortress and descend upon the neighbor who trusted the factory settings. This is the brutal pragmatism of survival. You cannot save everyone. You can only ensure that the violence stops at your threshold. Do not become complacent. The reinforced door buys you time, but it is not a magic shield. It acts as an alarm clock. The sound of a boot hitting a reinforced door is distinct. It is a dull, heavy thud that vibrates through the floorboards. That sound is your signal to act. While the intruder is struggling to understand why the door did not yield, you are moving. You are retrieving your defensive tools. You are ushering your family to a safe room. The scrap wood barrier has given you the gift of those precious, blood-soaked seconds that define the outcome of a confrontation. The world is becoming increasingly volatile. The comfort of the modern era has made us soft and trusting. We assume that the systems designed to protect us are competent. We assume the lock works. We assume the police are coming. Assumption is the mother of all failures. The universe tends toward entropy and disorder. The only thing holding that chaos at bay is the barrier you build with your own hands. Go to your garage, find the scrap lumber, buy the long screws. Do it today. Do not wait for the news report of a home invasion in your zip code to motivate you. Panic is a poor substitute for preparation. Look at your front door, not as a piece of decor, but as the primary airlock between your sanctuary and a hostile environment. Respect the gravity of that boundary. When you lock your door tonight, knowing that the bolt is anchored into the structural studs and the scrap wood is braced against the floor, you will feel a different kind of peace. It is not the false peace of ignorance. It is the cold, hard peace of capability. You have done the work. You have respected the physics. You have closed the breach. Let the others trust in brands and warranties. You trust in tensile strength and friction. The storm is coming, and it will batter against every house on the street. Make sure yours is the one that stands.